class number 3 of signal flow graph and block diagram reduction. So in this class we will see some more problems. Next problem is the block diagram of a control system is shown in figure. The transfer function Gs equal to Ys divided by Us of the system is. This is the system. This is the block diagram of the system. Now there are 4 alternatives given, and the question is asking about which one will be the exact transfer function of the this system, and this question has been asked in GATE 2003. So let us try to find out the transfer function. So at first there are 2 blocks here. One block is here and one block is here. There is an integrator. What do you mean by integrator? Integrator is nothing but integrator is 1 by s. So we can replace the integrator by 1 by s. Okay. Now let us draw the signal flow graph. So here it is the input. So let us write this point as RT, or you can say RS also. So this point as A. This is the summing point. This point is A. Again this point is as B. Okay. This point is again a summing point. So this point as C. And this point is again a takeoff point. So it will be denoted by T. And this is Y. Okay. Now let us draw the signal flow graph. So the signal flow graph for this block diagram will be, now signal flow graph will be, let us write here A, B, let us make it by black. So let us write here A, this is B, so this is C, and this is D, and again Y. Okay. So this point is R, this point is A, this point is B, this point is C, and this point is D. Okay. And again one more point Y here. This point is Y. Okay. Now from R to A we have to connect by a straight line between R to A, and from A to B there is another straight line. A to B there will be another branch. From B to C there will be another branch. From C to D there is another branch. From D to Y there is one more branch. Okay. Now from B to A, there is one branch having its path gain. Its path gain is -3 from B to A. From D to C, this is D and this is C. From D to C there is one more branch. Okay. And from D to A, so this one is one more branch. Now let us denote the path gain of each branch. Between R to A the path gain is 1. Between A to B the path gain is 1 by s, because it is an integrator. So we have to replace the integrator by 1 by s. From B to C the path gain is 2. Okay, this is 2. From C to D again integrator, so it is 1 by s. Okay. So now let us denote the path gain of feedback paths. So from D to C there is a path which has path gain 12, but it is negated because it is in negative feedback. So we have to denote it by -12. Okay. Again similarly here from B to A by -3, because it is again negative sign. From D to A again 9 with negative sign, so it will be -9. Okay. Now our signal flow graph is complete. Now we have to find out the total number of forward paths and total number of loops. So let me write here forward path. So let me write here forward path, here path gain, and here delta associated with path, delta associated with path. Okay, so the first forward path is what is the first forward path? R A B C D Y, and let me denote it path gain as P1. So P1 will be nothing but 1 multiplied by 1 by S multiplied by 2 multiplied by again 1 by S multiplied by 1. So how much it will be? It will be 2 by S square. Okay. Now what are the loops? So the loops are this is one loop A B A, this is another loop C D C, and this is one more loop D A B C D. So let me write loops. Loop gain. So what are the loops? The first loop is ABA. So let me denote its path is loop gain by L1. So L1 will be nothing but ABA 1 by S, the path gain of AB multiplied by -3. So it will be -3 by S. Okay. Second loop is nothing but it is DCD. So its loop gain will be L2 equal to what will be L2? So L2 will be equal to nothing but 1 by S multiplied by -12. 1 by S multiplied by -12. So it will be -12 by S. Okay. So now the third loop is D A B C D. Let us denote its loop gain by L3. So L3 will be DA -9 multiplied by, this is -9 multiplied by 1 by S, this is 1 by S multiplied by 2 multiplied by again 1 by S. So how much it will be? So it will be -9 by S square. Let us see whether any more loop are there or not. So let us see whether there is any more loop. So there is no more loop. So there are only 3 loops, and all the 3 loops are touching the forward path, the forward path R A B C D Y. So the delta associated with this forward path will be nothing but it will be 1 only. So delta 1 will be 1. Now what is delta? So delta will be, let me write here delta. So delta will be nothing but 1 minus L1 plus L2 plus L3, because all loops are touching each other. There is no loop because these 2 loops are touching. Okay, these 2 loops are also touching, but these 2 loops are not touching. Okay, because the loop number 1 and 2 are not touching at any point. So we have to write here 1 minus L1 plus L2 plus L3, here L3 plus L1 L2 also. Let me write this side. Let me write here plus L1 L2 also, because L1 and L2 are not touching. So delta will be this much. So now what will be the value of delta? So the value of delta will be 1 minus, what is L1? So L1 is nothing but minus 3 by s. L2 is nothing but minus 12 by s. Okay, L3 is nothing but minus 9 by s square. Okay, and what is L1 multiplied by L2? What is L1 multiplied by L2? So L1 multiplied by L2 is this will be plus minus 3 by s into minus 12 by s. So finally it will be, how much it will be? So it will be 1 plus 1 minus minus 15 s minus 9 s square plus 36 s square. Okay, so finally we will get 1 plus 15 s plus 45 s square. Okay, 1 plus 15s plus 45 s square. Now I think it is clear to all of you. So the transfer function will be, now the transfer function ts equal to sigma pi delta I divided by delta. We have to apply Mason's gain formula. So p is nothing but there is only one path, so 2 by s square multiplied by 1 divided by, we have got delta as 1 plus 15 by s plus 45 by s square. Now what we have to do, now we have to multiply each term by s square, the numerator and denominator both by s square. So if we multiply the numerator and denominator by s square, so it will be, how much it will be? So numerator will be 2 only, because in numerator there is no alternative which is having any other value than 1. So numerator will be 2 by here s square plus 15s plus 45. Okay, now if we see which one will be the correct option, so we can see that this one will be okay. One more thing is here, 36 plus this is 9 by s square, L1 plus L2 plus L3. So L3 is it is I have written it wrongly, but it will be 9 multiplied by 2, so it will be 18. So it will be 18, not 9, it will be 18. So we have to make this change always. So this will be 18, this will also be 18. Okay, I have made this mistake. So 18 plus 34, this will be 54. So this will be not 45, this will be 54. Okay, so again this will be 54. Now it is okay. Here also 54, not 45, it will be 54. Now if we take here 54 as common, so it will come like 1 plus 15 by 54 s plus s square by 54. Okay, plus s square by 54. So which of the given options are correct? 9 multiplied by, so it will be nothing but it will come like 1 by 27 into 1 plus 15 by 54 s plus s square by 54. Okay, now which of the given options are correct? So I think this option is correct, because yes, if we multiply these two terms, so it will come 1 plus s square by 54 plus 15 by s. So option number B is correct one. Next question is for the block diagram shown in figure C, S divided by RS is given by. This is the block diagram given, and there are 4 alternatives given, A, B, C and D, and this question has been asked in GATE 1996. So let us try to solve it by the use of signal flow graph. So let us make first the signal flow graph. Before that, let us name out the points, different points in the block diagram. So let us name this summing block, the first summing block as A. Okay. The second summing block as B. This takeoff point as C, and this takeoff point as D. Okay. So now we have denoted, there are total 1, 2, 3, 4, 5, 6. There are total 6 points. So let us denote here the 6 point. 1, 2, 3, 4, 5 and 6. This is ours. A, B, C, D, and let us write here. This one is C dash, because it will we will get confused with two C's. So it is C dash, and this one is final point is C. Now from R to A there is one branch. From A to B there is another branch. From B to C dash there is one more branch. From C dash to D there is one more branch. From D to C there is one more branch. Okay. Now from D to B there is a feedback branch from D to B. So from D to B there is a branch from D to B. Okay. From D to B. Okay. Now from C dash to A there is one more branch, C dash to A. This is C dash. So from C dash to A there is one more branch. Now let us denote the path gains of each branch. So the branch gain of branch between R and A will be 1. Between A and B will be G1. Between B and C dash will be G2. Between C dash and D will be G3. Between D and B will be minus H2, because here it is negative feedback, so we have to write here minus H2. And from C dash to A we have to write minus H1. The reason is same here, it is also negative feedback. So now let us write what are the forward paths. So here let us write the forward path. Forward paths. Here write path gains, and here write delta associated with path. Delta associated with path. Okay. Now what are the forward paths? So as we can see there is only one forward path. So the forward path is R, A, B, C dash, D, R, A, B, C dash, D, C. Let us denote this path gain by P1. So P1 will be nothing but this 1 multiplied by G1 multiplied by G2 multiplied by G3 multiplied by again 1. The path gain from this path is also 1. That's why it is 1. So it will be G1, G2, G3. Okay. Now what are the loops? So let us write here loops, and here loop gain. So the first loop is So here the first loop is C dash G, C dash A, C dash A, B, C dash. Let us denote its loop gain by L1. So L1 will be nothing but C dash A minus H1 multiplied by G1 multiplied by G2. So how much it will be? So it will be minus G1 G2 minus G1 G2 H1. Okay. What are the other loops? The other loop is D B C dash D, D D C dash D. So its loop gain will be L2 and it will be minus H2 multiplied by G2 multiplied by G3, and this will be equal to minus G2 G3 H2. Since these two loops are touching the forward path, so the delta associated with this forward path will be 1 only. So delta 1 will be 1. Now what will be the delta? So delta will be, delta for this system will be 1 minus L1 plus L2. So it will be nothing but 1 plus G1 G2 H1 plus G2 G3 H2. Now the transfer function will be transfer function Ts is equal to nothing but sigma Pi delta I divided by delta. So it will be, since there is only one path, so G1 G2 G3 divided by 1 plus G1 G2 H1 plus G2 G3 H2. Now let us see which option is correct. So in numerator G1 G2 G3, all are having G1 G2 G3. In denominator 1 plus G1 G2 H1, 1 plus G1 G2 H1 and G2 G3 H2. So option number A is correct one. Okay. The next problem is the signal flow graph of the figure shown below has fill in the blanks forward path and fill in the blanks feedback loops. So this is a fill in the blanks type question and signal flow graph is shown here, and this question has been asked in GATE 1991, and the question is asking about how many forward paths are there and how many loops are there, feedback loops are there. So let us find the forward paths. So let us write here the forward paths. What are the forward paths? Forward paths. So let us write first x k m y g y x. Let me write it as k m g y. This is the first forward path, x k m g y. The second forward path will be x k l f g y, x k l f g y. Third forward path will be x h f g y, x h f g y, x h f g y. The fourth forward path will be x b d f g y, x b d f g y. Let us see whether any more forward paths exist or not. So there is no more forward path, because from here there is two forward paths. One is here and another is here, and from here there is two forward paths. One is here and another is here. And how many loops are there? So feedback loops, feedback loops. So let us name out here. So first feedback loop is M N M. Okay, M N M. Okay. The second feedback loop will be here C Okay, third feedback loop will be EDE. Okay, this one. The fourth feedback loop will be I think this one is this. Okay. So from here there is one feedback loop, and another feedback loop will be here N L F N. So there are N L F N N M N. There are two feedback loops here, and here one feedback loop, and here one feedback loop. Let me see, is there any more feedback loop or no? So from here we cannot go here. So from here also we cannot go here. So there are 4 loops only. So there are 4 forward paths and 4 feedback loops only. So both loops and forward paths are equal. So there are 4 forward paths and 4 feedback loops. So now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.